Hello, it's Steve. Last time in this series we parsed our map data and printed the numbers out to the screen like this. Today, let's get a little bit closer to actually rendering our map by going through and parsing the sprite files as well as the template files. Before we get too far into it, you'll notice that our asset loaders look a little bit different. That's because I had to downgrade to Bevy 013 for various reasons, but if you want to see a video on my NixOS setup for this, let me know. If you're familiar with NixOS, here's my flake. Kind of use this same setup in order to get Rust and Bevy working on Nix. But anyway, enough of that. Let's get into it. First, we'll convert our map data that is currently just a string into some actual valuable information. In order to do that, we need to create a new asset type to hold that data. So this will do for right now. In a little bit we're gonna probably add a few more properties, but now we'll just pull the width, the height, and the data just to confirm that we're doing this right. Down in our loader we actually want to load our raw map data instead of a map, and that'll change what we do here too. So let's just get rid of that to start with, and let's return just some temporary data to stop the compiler from yelling at us. Now here we've grabbed the file data from our bytes and returned an error if it's an error. You could normally use a question mark here, but as we explained, I think in the last episode, it's a different type of error, so this sort of thing I think is necessary. Now let's convert this into a document like we were doing in our other file. And actually, before we get too far into parsing this document, let's take a look at the map file so we can figure out where this data that we're looking for is stored. Three things we're looking for right now is the width, the height, and the data. So we need to find this layer element as well as the data element. The way that this format is set up, clearly intended to have multiple layers, but the way our game is set up, we're only really going to need one. So to make it easier on ourselves, we'll just look for the layer and then we'll look for the data, and that's just all there is to it. If there were multiple layers, then this wouldn't be a good solution, but we're keeping it simple on ourselves. Alright, there's the element containing our layer. Let's also grab the numbers inside of data. And there we go. We're using this text function to grab the text inside of the element. We're expecting on multiple cases, so if anything goes wrong, we can figure out where exactly it went wrong. In my opinion, this is good practice for a very tight tool like this. We know the shape of our data, and so if anything deviates, then we know that we need to update our parsing. This floor string is going to have a bunch of new lines and characters that we don't want. We want to turn this into just a CSV, so let's get rid of all the extra characters in here. We're going to have to make this mutable so that we can go through it and remove all of the new line characters using the retain method, which takes a predicate. That'll remove everything we don't want from there. In fact, I bet the is white space, yeah, it looks like that probably also covers a line break, but I'm not going to mess with it right now. We probably don't need to do this direct match with new line if we're using the is white space. Now for the floor data itself, now we have a set of strings that represent these numbers. Now let's start grabbing the values that we actually want. Now this is a bit of a repeated pattern. Theoretically, we could break this out into a function, but there's a lot of very custom. First of all, we would have, if we think through that process, we would have to include all three of these strings as well as the type that we want to parse. And at that point, it's going to be almost as long. So just instead of saving screen space, it's not going to be that time saving. So I'm not going to bother right now. It's not that much more verbose. Alright, so there's the width and height. So now we can actually go and just get rid of these, and that'll automatically put these into the width and height values of the map data. Next up, we need to initialize the data vector. This is going to be of size width times height. That is the area of a square. I don't know, is that middle school math? Now let's iterate through our floor data. And we're going to need an index counter here. Now we can set the data at that index to the parsed value of this number. And I need to make this mutable. Mutable data. All right, so now we have all of this useful data all stored in a nice way. Let's also make sure we update this to raw map data, because this is what we're going to be loading. Now jumping back over to main, a few other changes we need to make. Raw map data, and this is a set of raw map data as well. We don't need read-only XML tree here anymore, because instead of doing all this, we are going to be printing out the numbers in a nice, handy way. Now, this is fairly straightforward, but just to go over it real quick, this is going to go over each row and then each column in that row and print out those numbers and then print a line for us. So if we go ahead and run this, we should get a much cleaner output than before. And look at that, it looks like a map almost. Isn't that cool? That clears the groundwork for us to also load in the tile set and the templates files. I'm going to kind of skim over a lot of the boilerplate in these because it's nothing you haven't seen before at this point, but I'll try and point out some interesting things along the way. To start with, we can nuke our map asset. We don't need it anymore. And let's build up the rest of our data structures before we get into anything in particular. Starting with our map data, we're including 2 additional properties, which is the set of objects on our map. So if we see down here, there's a little list of objects, so that's what we want to include, as well as a link to the tile set itself. If you're probably familiar with this handle object, this is what gets generated when we load something from here. This is what gets generated when we load something from the asset server. There's also another way to load things, which is from the load context, and I'll show you that in a second. I'll show you that after we're done laying out our data. Now here's the object reference struct. If we look into one of our more complex tile maps, you can see that these objects have an ID that we're not using, as well as a link to our template, an X and a Y, and a list of property overrides. Now, template data, unlike object reference, which is just going to be used inside of these assets, template data is an asset type of itself. This is representing these template files, so it needs to be an asset, which is why I'm using these derives. Let's go peek at template data just to make sure we have all of the things: sprite sheet, sprite index, and properties. This is our tile set, is this what we're calling a sprite sheet. Our sprite index is this GID right here. As you can see, between the planks trigger and the teleporter, they're the same. And it's kind of a confusing naming convention if you ask me, but whatever. And then our properties you saw in there, they're listed just like they are in the object. Next up is our sprite sheet data asset. Now, since our sprite sheet is just one row, we know it's always going to be one row. That's just kind of the design of our sprite sheet. I don't plan on changing that, so all we really need is a columns number, which actually we're probably not even going to use that either, but we have it in case we need it. Also the tile width, which is going to remain constant as well at 16, but might as well hold on to that, and the sprite handle for the image. If just one more time we take a peek at this file, you can see we have columns in here, we have tile width in here, and we have a link to our sprites PNG, which is right there. Let's fill in the rest of the data, which is, I think, the object property is going to be our last thing. Now, these object properties can be of multiple different types, and we could do some fancy enum things with Rust, but having gone a little deeper into this project, that gets pretty complicated and annoying. So for right now, we're going to do it this way. So let's go ahead and define that object property type enum down here. Okay, and with that, that's all the things we need right now. I'm going to sort this a little bit so it's a little bit less annoying to look at. We're going to put a little tag for assets up here, and a tag for I don't know, miscellaneous structs down there. I'm sure there's a better name for that, but that's what we're going with. And before we forget about it, let's go down here, and we have a few more assets to load in, which this means we have to now define the sprite sheet loader and the template loader. And this video is already getting pretty long, so I'm going to cut it off there. Next time we'll go through adding these loaders for template and sprite sheet data. And hopefully in the video after that we'll be far enough along to get to rendering sprites to the screen. Thanks for watching. Peace.